next question, number 6. Okay, so it says a 3-phase balanced load which has a power factor of 0.707 is connected to a balanced supply. The power consumed by the load is 5 kilowatts. The power is measured by 2 wattmeter method. So because it's 2 wattmeter method, we have 2 wattmeters. The readings of the 2 wattmeters are, we have our options A, B, C and D. Okay, so let's first write down what's given to us. We have the power factor cos phi given as 0.707. So if cos phi is 0.707, phi is cos inverse of 0.707. Now if you calculate this, it comes to 45 degrees. Now the power consumed by the load is a total of 5 kilowatt, which means that 5 kilowatts is split by the 2 wattmeter method. The readings of the 2 wattmeters must add up to 5 kilowatts. Okay, keep that in mind. So let's call our 2 wattmeters as W1 and W2. So if the total power consumed is 5 kilowatts, then that means W1 plus W2 equals 5 kilowatt. Let's call this equation 1. Now for a 2 wattmeter method, recall the formula for angle. Now you should know that the angle is measured in terms of tan, right? So it's tan phi. The formula is tan phi is equal to root 3, it's a 3-phase balanced load, right? So root 3 into W1 minus W2 divided by W1 plus W2. Now this is an important formula. Okay, so from this formula, we will be able to obtain another equation in terms of W1 and W2. So let's substitute the 45 degree angle here. So we get tan 45 is equal to root 3 into W1 minus W2 divided by, now W1 plus W2 is 5. So we'll note that down, 5. We don't have to write it in terms of watts because our answer is in terms of kilowatts. So we'll leave the value as 5. Okay. So now if we solve this, tan 45 is 1. So that's 5 is equal to root 3 into W1 minus W2. So here we will get W1 minus W2 is equal to 5 divided by root 3. So this is our second equation. Now if we solve equation 1 and equation 2, we should be able to get two values, W1 and W2. Now I will leave that solving part to you because they are two equations, linear equations in two variables. I'm sure that you're very familiar with solving that. You can use a calculator and enter the two equations. So we have W1 plus W2 is equal to 5. W1 minus W2 is equal to 5 by root 3. You can use any method here. You can directly add the two equations. W2 cancels out. So here you will have 2W1 equals to 5 plus 5 by root 3. Either way, solving the two equations above, you will obtain two values, W1, W2. Now I will leave that solving part to you. Check and see if you get these values. W1 should be 3.94 kilowatts and W2 should be 1.06 kilowatts. So these are the final answers, and this matches option A. So this is the final answer. I hope this has helped.